Okay, we just need to deal with a very small issue, and hopefully we won't come across this too often in the internal, though it will come up in the external. So when you come to drawing gradients, in this first example here, it's talking about if you've got a gradient m equals 60. And we think about how do we actually draw that. So let's have a look at what the axes have been set up to be. Now these axes are not equal. Okay, 1, 2, 3, 4, 5. This is only going up to 10. Whereas this axis here is going all the way up to 600. So we've got to think, how do I draw a gradient of 60 when my axes aren't equal? And what we do in this case is we take, right, we've got our gradient m of 60. I need to make this into some equivalent fractions. Now, I can take 60 and divide that by 1, because that's always allowed to divide by 1. So now let's find some other equivalent fractions. If I multiply top and bottom by the 2, so 60 times 2 would be 120 over 2. And now I would have a look at my grid and say, okay, so if I went across 2, could I measure going up 120? Maybe, but it might be getting a little bit difficult. So let's try another option. What if I take this original fraction here and I say 60 times 3? Would that be any nicer? So 60 over 3, so 60 times 3 would be 180 over 3. Now is that going to be any nice? Well, it's still not going up by a whole number. If this was going up by like a whole number, like 200, 500, something nice, that would be much easier to do. So let's think, well, what if I want to get it up to a multiple of 5? So 1 times 5 is 5. 60 times 5 is 300. Now we've got a nice number. So now I can look at that and think, right, if I go across by 5, I can go up by 300, and that's a nice easy coordinate for me to make. Okay. Equivalent. Oh, I could extend that further and go all the way across, 10 across and up to 600, and that would have been fine too. So it's just a matter of finding the right ratio to get it to a nice value. Okay, so that was the first one. Let's have a look at the second one. The second one has a gradient of -2 over 5. Now it's negative, so what does that mean? Well, negative means that the line is going downwards. Okay, -2 over 5 means that, remember, that's our rise over run. So that means we're going down by 2 units and across by 5 units. So what's our axes? Let's look at the scales there. So we're going 10, 20, 30 across that way and 10, 20, 30 that way. But it's certainly more, the data's a lot more squished this way than it is that way. So we've got to be careful about this. So let's find some equivalent fractions. So I'm going to take -2 over 5. And say I multiply that by 2. That would give me -4 over 10. Is that a nice one to do? Going up and down by 4 is not great. So what else could I do? Well, let's think, what if I was to multiply that by 10? So 2 times 10 is 20, and 2 times 5 is, yes, 2 times 10 is 20, and 5 times 10 is 50. Goodness, my brain just went blank. So what we want to do now is, as we go down, we're going to go down by 20 units, and we're going to go across by 50 units. And that's a much more reasonable thing for doing for the grid that we happen to have.